Today in the garage, we're recording live at AutoTech Detroit. My guest is Joe Capuano, who's head of technology for Bosch Mobility Americas. Joe has an incredible 37-year career in the automotive industry and 30 years at Bosch. In today's conversation, Joe shares his perspective on where we are on the journey to SDV, the importance of system-level thinking across a range of this vehicle design price points, and how AI can help us manage the growing amount of data that vehicles and SDVs will create. I think you're really going to enjoy today's conversation. Let's go. Welcome to the garage. I'm John Heinlein, Chief Marketing Officer with Sonatas. We're recording live at AutoTech Detroit in Novi, Michigan. That's the background noise you may be able to hear during the show. Our guest today is Joe Capuano. Joe is Head of Technology for Bosch Mobility Americas. Joe, welcome to the garage.
John, thanks for having me.
So we always like to have our guests introduce themselves and tell us about your background. Tell us about you.
Sure. I'm responsible, as you mentioned, head of technology for the mobility sector in Bosch Americas. I also have a second role, which is I've been doing for 4.5 years, which is head of Bosch Engineering North America. So responsible for all the Bosch products, but selling mainly to smaller customers or in smaller volumes and some other niche parts of the mobility industry. My background, I'm a computer engineer. Have worked in the automotive industry 37 years now, 30 years at Bosch.
Congratulations.
Thank you. Doing basically working in engineering of all different automotive systems that you can imagine, powertrain, chassis, convenience systems, very heavy effort and emphasis on software, electronics and software, digital electronics and software that goes along with it, and have launched several products into production with our North American customers. I've also spent 5 years in Europe at our Germany facilities at Bosch, learning the culture, working together with European customers and my European counterparts. All in all, been a great run.
That's fantastic. You know, one of our Sonatas team members you may know worked with you in the past, and when we saw you were on the roster for this event, he said, "Oh, you got to have Joe on the podcast." So we're thrilled to have you. You got to also start us off with a fun fact about you.
Yeah, so I'm an avid two-wheeler guy. I love motorcycles, bikes, mountain bikes especially, and over the course of the last 15 years, I have gone coast to coast, from Newfoundland all the way to the edge of Canada and all the way to Prudhoe Bay, Alaska by motorcycle.
Wow.
Without staying in hotels. So with a backpack and a tent and kind of roughing it a bit. So,
that's incredible.
A very big adventure, and it was kind of a dream of mine to do that.
That's phenomenal. You must have seen the Long Way Round series.
Oh yes, of course.
That's an amazing series, and so I feel like that's the adventure you lived. So hats off to you. I always like to say something to match our guests. I have no experience motorcycling, and I definitely have not spent as much time in Canada as you have. I feel bad about that. I should do that. But I used to be a cyclist and a triathlete, so I did that for some years, and that was a great experience. So tell us about Bosch in general for our guests. I mean, it's a famous company, but just a little context about Bosch in general, and then also what do you work on?
So Bosch is the largest automotive supplier in the world, 120 years in the U.S., nearly 60 billion in revenue in automotive in 2024. So full range of portfolio products represented in every automotive region in the world. Anywhere vehicles are made or sold, you find Bosch service, you find Bosch parts, aftermarket parts. A very broad portfolio of components. We're supporting nearly every customer in the world in one form or another through our products and services. Manufacturing is a key core competency at Bosch. But software is also now a core competency at Bosch, and something that we're taking very seriously as we move into this SDV realm in the future.
Great. And what sorts of products do you focus on yourself?
So I personally have worked the longest in powertrain at Bosch. I was responsible for our powertrain controls business unit for over 10 years in the US, and that's one of our prime product pieces out of the product portfolio. We provide full fuel systems, but the controls, the controller and the software are also very critical to the functionality of the systems. And so that was a big area I was in. I was also in safety electronics, airbag, occupant sensing, And in my role at Bosch Engineering that I've been in the last 4.5 years, we support all the products of the Bosch portfolio. So it's a very unique role that I have, and a very unique job, because essentially any hardware that Bosch makes, I can apply to smaller customer volumes. So we take off-the-shelf hardware, we are able to customize the application, the calibration, the software, and then provide the benefits of high-volume electronics to smaller applications. But we do that across the full product portfolio, so I see all of the Bosch products.
That puts you in a really great position to see the whole landscape. That's really fantastic. So I wonder, we often talk about SDV and software in this podcast, and in general, it's important to Sonatas and important to the industry. We were chatting about SDV. I'd love to get your take on where we are in the SDV journey and how are things going.
To me, SDV is more like a continuum of actions that have started with the advent of ECUs in the vehicle. So when I first started working in automotive, I was working on engine control modules that could not be flashed at all. So they only had one-time programmable memory, and they worked very much in a localized domain. So there were sensors, but there was no high-speed bus activity necessary because the system was standalone. It did what it had to do. It met regulatory requirements.
Right.
But it was a single piece in the vehicle, and probably the vehicle just had a couple of things like that.
Sure.
But then additional functions came along, like ABS. And all of a sudden, once we had ABS, we could control wheels. The two systems, powertrain and ABS system, needed to talk to each other. So by expanding the functionality, we wanted to add traction control into our ABS system. We had to be able to manage engine torque. And that initially was not done via some complicated CAN bus or something like that. That was done with pulse width modulation.
Really?
So there was a torque received, a torque requested, torque received signal. And that's how the communication went. But you can imagine already people were thinking, couldn't we somehow combine these two pieces that we have together? But the technology just wasn't there.
Right.
The microcontrollers, the memory, it was extremely expensive back then to add a lot of memory and computation power into systems. And to a certain extent, the take rates weren't always supporting going to a completely new architecture.
Right.
But I would say the writing was already on the wall early on that someday we're going to get to the point where we bring things together because it makes sense from a take rate, from a complexity, from a pricing standpoint. And we're kind of at those days now. As we have over 100 ECUs in many vehicles, it's just impossible to continue at that pace with such a distributed network. You have to look at centralized opportunities.
Right.
And really the big motivation for this is autonomous. Because once you have autonomous, nearly everything in the vehicle has to be able to be controlled by a central computer. And to do it all via buses, even Ethernet and very high-speed buses, just becomes too complex.
Well, we were talking about the optimism versus the reality of this. And indeed, autonomous driving is an area I'd worked on before. And you mentioned you've worked on, it's still something that's very much evolving. There's fantastic progress. Waymo and companies are doing incredible work. Obviously, L2+/L3 systems are beginning to roll out from the leading edge vendors, but still a lot of it's in front of us. Maybe we can talk about the optimism versus reality in SDV progress in various aspects.
Yeah, I think on the autonomous side, it's coming. But none of us can put our finger exactly on the timeline to say when that is. But SDV needs to be there to support even the advanced driver assistance functions and safety functions. For example, automatic emergency braking is a function which is becoming mandated, federally
and CAP
mandated.
Required as well, yeah.
And so you have to combine the data from several systems to be able to do the things that you need to do to support that functionality. So I see the roadmap as an evolution. Of course, there's a revolution would be level 5 autonomous comes, and it comes very quickly, and we have to make a complete paradigm shift. Sure. But really more what's happening is that it's a gradual increase with certain functions like AEB becoming mandated, becoming mainstream across the application. Yep. We're taking a step toward looking at opportunities to combine functions together in that case. And we can't ignore the connectivity issue either. The vehicles are just becoming more connected because of additional convenience functions and the things that we talked about in the panel today, with the need to have data available to develop new vehicles. There's marketing, and obviously there's other aspects with respect to what's done with the data. So connectivity and AV together are really driving the topic, as well as just the number of ECUs and complexity of the vehicles.
Right. So imagine a skeptical listener says, "Oh, okay, AV is going to be in the future, and I don't need to worry about that today." The reality is, as you said a minute ago, that there's still a need to solve these problems today for passenger vehicles of today, and probably trucks too. I mean, we often talk only about cars, but the benefits to trucking is equally important. So if we talk about non-AV applications for a minute, let's explore some of the benefits you're seeing with, you mentioned hardware consolidation. That can be a cost savings and a simplification. You mentioned wiring. What are some of the areas you think are the most promising short of AV for SDV?
Yeah, I think the digital cockpit is obviously a component of the SDV, the need for SDV. We have a lot of decentralized control units in the vehicle. And I think there's opportunities like in motion control to bring functionality from powertrain, from braking, and from other domain steering and other domains together into motion control. There's vehicle integration platform, which is a Bosch product where we're bringing more vehicle functions together as well. These are operating at the next level up in terms of the architecture. They need to share data and communicate to the outside world very differently than what we see from a decentralized component, which is an actuator or close to the actuator.
Right.
In all of this, you have to consider the system. And I'm a big believer in doing good systems engineering. You have to look what you want to have, what is inside your system and what is outside your system. The simple example I always give is an accelerator pedal. If you say the accelerator pedal is my system and you draw the circle around it, the input is someone's foot applying force to the pedal, and the output are voltages on the potentiometers. But to the consumer, the system is I press my foot on put my foot on the pedal and the vehicle drives. If I draw the box like that, I have to include the complete propulsion system inside the system. That changes the system challenge I have, and it changes the architecture that I would approach the system with.
Exactly. I mean, it changes the scope of thinking, and you mentioned the so many hundred ECUs and so on like that, and on the one hand, you could argue, oh, that's a really smart division of labor, so you can divide labor. But no one would design it that way if you started with a clean sheet of paper with today's technology. So as you look at, and you're talking to so many OEMs, and you have such a great view of the industry, there are many different choices about how future vehicles can be architected. Just yesterday, you may not know this, just yesterday we released the results in collaboration with Wards Intelligence of the 2025 SDV survey, looking at key industry leaders, around 600 industry leaders talking about their view of where vehicles are evolving. And what you saw was a range of ideas. There's no single architecture, there's no single view of that. So I'd love to get a sense of your survey of one. What's your sense of where do you think the industry is going to go as the predominant direction, ranging from today largely totally decentralized to one big computer in the middle and no other computers there? Probably the answer is somewhere in the middle. Where's your take on that?
The answer, unfortunately, is it depends. So if you take customers, as you mentioned, that are designing really with a smaller legacy footprint from a clean sheet of paper, they can be very aggressive in terms of how they optimize their architecture. Their system is smaller in terms of requirements and legacy needs than someone might have who has been producing vehicles for 100 years or more. So I think we're going to see a lot of different solutions. It's going to be a stepwise approach for the larger customers. They can't abandon some of the components and some of the legacy that they have from the past. They can't make a jump to a brand new architecture and leave everything behind where they still have a lot of profitable product potential. But they need to make the step in parallel. And I talked about it in the panel. It's not, some of these features, non-regulatory features, are not going to have 100% take rates. So architecting a system which has a lot of expensive components in it in terms of compute power and distributed ECUs, that has to cover also a lower end vehicle, that will add cost to the vehicle. And I see an overriding theme I see in my personal life as well as at Bosch is the affordability of transportation. And we have to keep in mind that, yes, some of these systems are there's a lot of creature comforts available, but they're not required to have mobility, and our systems have to be flexible enough to be able to deal with the lower end vehicles, but still support the higher end vehicles without having two totally separate electrical architectures, which is very expensive for our customers to carry.
Yeah, that last point is a really important one. And we've had other guests this week talking about exactly that one of the potential promises of SDV is you can have a common architecture and yet intercepts at different price points. So the validation costs, which can be significant, the design costs, engineering costs can be reused, but recognizing that some will be more outfitted, as you said, take rate than others. Do you see that as the kind of the direction of travel where there's a common framework and a common architecture, but different price points?
Yeah,
it's not the way it's done today.
Yeah, this gets into a question of scalability. Right. So, if in the past the way that was done was, you had microcontrollers, generally speaking, in our right. separated ECUs, and our distributed ECUs, and you had a microcontroller family, and you could scale the microcontroller and the software to fit the application within a family. We need to see that same level of scalability at the microprocessor level, what you're operating at the vehicle control unit level, and in this more common, with a lot of common inputs, a lot of non-distributed functionality, like some of the functionality we spoke about before. We need to have the scalability to enable us to provide lower end solutions within the same architectural framework. And the second aspect, I talked about it as well, standardization.
Yeah.
So the interfaces need to be standardized enough that we can use those interfaces both for lower end applications as well as higher end applications without causing a tremendous amount of additional work for the engineers and validation and integration and the things that really drive development timing and cost. Those two things need to come together. I think they will. So I think, and we're seeing signs of it already. There won't be a big bang SDV, at least that won't be the mainstream solution, I believe. It'll be an architectural evolution. Some elements will be brought in, some scaling components will be brought in as well, and the next generation will bring more in and bring more flexibility and more standardization, and finally we'll end up eventually in an architecture which is, I guess, what we would call fully SDV, fully minimizes the amount of discrete components and maximizes the amount of integrated components in the system.
So a couple you mentioned such interesting points there. One is that the importance of having scalable performance points. So you have a processor or a vehicle processor, but that has higher performance and lower performance offerings, but are software compatible.
Yes.
So that's one of the points you made. I'm wondering, where do you come down on the kind of the zonal architecture consolidation? Because today you have these end sensors, distributed parts of the vehicle, whether it's ABS or ultrasonic or whatever they are around the vehicle. How much of that do you expect is going to get to consolidate into zones so that you still have software, but those microcontrollers or combination microcontrollers, microprocessors are in the quadrants of the vehicle? Do you see that as a direction of travel?
Zonal architectures are a big discussion point right now, and several customers are moving in that direction. Which sensors and which functions are integrated varies, I would say, by customer, and this is a challenge as a supplier. We need to still provide discrete solutions, but we also have to provide integrated solutions, and the software can't be totally rewritten between discrete and integrated. So we need a kind of API.
Kind of a graceful transition path.
We need a graceful transition, but as a supplier, I'm pretty certain we're going to be required for a relatively long period of time to provide both.
Yeah.
We can do that in a smart way by defining the APIs. By really getting into the middleware that we talk about within our zonal architectures and making sure that the software is written with standards so that we can utilize the software from the discrete side in the zonal side as well, with a minimal amount of integration effort and a minimal amount of adaptation. So every customer is going to draw their circles differently in terms of what gets integrated, what doesn't. It's also highly dependent upon bandwidth of the data, and if you want to bring the data from a radar to a central ECU, you're going to have to do some pre-processing at the source,
right?
Which is basically another discrete ECU,
right?
It's just the bandwidth of the data becomes, in some sensor technologies, becomes prohibitive to be able to have just one ECU with dumb sensors around the vehicle.
Right. You mentioned some different networking technologies. Obviously today proliferation of CAN and many other solutions like that. How much do you see the take rate of automotive Ethernet as the next generation backbone? Because it simplifies the wiring harnesses so much,
Yes.
But it's a big change. What's your take on the timeline of that?
I mean, it's an integral part of the SDV architecture. So I think you'll see that coming in many different applications in the next few years.
That's great. You also mentioned standardization, both standards bodies and also standardization of interfaces. Are there particular standards or standardization bodies that you think are particularly important and relevant?
Yeah, so we spoke about Covisa. That's obviously an important aspect in SDV. I mean, AutoSAR Adaptive are continue to develop standards which are critical for SDV adoption. There's also a lot of standards at the cloud level that are being brought in. We had discussions about those during the panel discussion as well. These are all important aspects to be able to get to a real SDV architecture, and they're going to continue as well.
One of the things that came out of the SDV survey we talked about is a growing appetite for CI/CD and virtual prototyping. That's one kind of, if you will, corollary benefit that comes along with SDV that can also, in a sort of virtuous cycle, help to accelerate the adoption of SDV and bring other benefits like cost reduction and so on. I know that that's a key, something you care about as well. Can you talk about your take on virtual prototyping, digital twins?
Sure. All these issues are tied together. The more data that we get from the vehicles, also from the field, the more that can feed back into our development process and improve our future products. So this is I would say SDV is an enabler toward more data. Really, in the end, we're getting so much data now, it also becomes an issue, what do we do with the data? And do we have the right competencies and people to work on that data? And we're working very hard at Bosch. We have AI Training Institute within the company, which is focusing on software for all levels, executive all the way to our new hires. We're working on, kind of volunteer types of working groups within the company where people sit down and work with different tools, Python and other things to be able to work and look at what the environments look like. So we have a very experienced group of automotive professionals at Bosch, but not all of them have been trained in AI and AI tool sets and methodologies. And so we need that domain knowledge. It's absolutely critical to Bosch's success, and I believe the market's success, that automakers and tier suppliers maintain their automotive domain know-how, but they need to bridge into this tech world where we talk about AI development tools. And really, AI has the potential to, not just in the prototyping part, but the entire development cycle. There are tools out there now to facilitate that and make better use of model-based development. The days of needing to sit down and code anywhere in the world are slowly coming to an end. And we have to really operate at that next level of AI integration where the tool sets are developed and our engineers are trained to take advantage of everything which is available to them.
Yeah, AI is such an important topic. First on the narrow point you made, and then I'll speak more broadly about AI. You mentioned about the importance of using AI for data mining. That's not the exact words you said, but that was the idea. It's interesting. I'm smiling because right behind that wall, we're showing a demonstration of exactly that, how we've come up with a solution as well to take that same idea of helping OEM engineers to be able to do more detailed queries with natural language more easily,
yes,
instead of having to program at the low level and know exactly which weeds level signal. That's crazy. Why don't we use AI to accelerate that? If I pull back more broadly on AI, one of the other conclusions of the survey I mentioned earlier was looking at, we asked our survey participants, what are the most promising applications of AI in vehicles? And it's so interesting, the results. 4 of the 5 of their top answers were things that are largely not deployed today. Number 1 is vehicle diagnostics, using AI to find and fix problems. And number 2, I believe, was vehicle tuning and optimization, things like using AI to do ongoing performance optimization, efficiency optimization, and so on. Vehicle personalization was one of them. And number 4 was, okay, IVI and navigation, you'd expect that. But so fully 4 of the 5 top applications were not deployed today. So huge opportunity to deploy into the vehicle. And then you made a broader point about AI as a tool. AI is of course it's a big buzzword today, but the fact is it's such a powerful capability for so many things, improving productivity, improving design cycle, improving effectiveness. It's exciting times to watch how it's being used across the space.
Yeah, absolutely.
You mentioned also that you deal with large customers, you deal with small customers. I wonder if you can share some of the learnings you've had about some of the things you've had to do differently with large and small customers.
Yeah. So most of my Bosch history is working with large customers. So in powertrain, combustion powertrain, for example, there's a lot of large customers in the U.S. that we work very closely together with on software and some of the topics that we talk about, but it was more in a traditional architecture.
Yeah.
When it comes to newer customers, there's obviously a lot of flavors of new customers. Most are very eager to make rapid advances in development to get their first vehicles out to market as fast as possible. And so they're not always so interested in finding the optimal electrical architecture. They want off-the-shelf product, they want it adapted for their needs, and they want it as fast as possible, meeting all the requirements that they have. But there are also customers that we work with that also are working more on a blank sheet of paper side and say, okay, we have a lot of flexibility here and latitude in what we can do. We have kind of our guiding light is where this is the direction. This is the DNA we want our vehicle to have, but let's work together on what you can bring to the table in terms of advanced architectures to have us really be able to do the types of things that we want to do with the vehicle, user experience wise. So very fast, flash over the air cycles, continuous improvement. This customer expectation, the vehicle on the first day is at its worst rather than at its best, right? So we want improvements over time. We can build those things in for those customers, and obviously those are big issues that we deal with as well with our larger customers. But many customers, as I said, are just saying, "Get me into production as fast as I can, so that we can have product on the market and we can begin a cash flow stream." So we're dealing with both extremes in terms of what we deal with in the market.
We've been talking a lot about or implied passenger vehicles, but I assume a lot of these same trends apply to commercial vehicles as well. Do you get exposed to commercial vehicles?
Yes.
And what are some of the issues you see there that may differ or be common?
Yeah. Commercial vehicles have different set of regulatory requirements, so there's differences there. Obviously, volumes are lower. We deal also with off-highway vehicles, and the SDV over-the-air topics are really prevalent there. So smart farming, for example, and cloud connection is critical to getting data about the fields and lining your tractors up and rowing and mowing in the proper spaces and treating bugs and things only where it really needs to, minimizing the use of pesticides. They're actually quite advanced on the off-highway side. I would say even more so than what we deal with on the passenger car side. So these SDV elements, central computing and connectivity systems are prevalent in off-highway especially. We also deal at Bosch Engineering with rail. So we really deal on some of the non-traditional mobility side with safety systems. So we have our tram collision warning system, forward warning system. We have activities in other spaces as well. I mentioned off-highway, we're selling components, radar and other components in off-highway. So we're getting exposed to how the different customers and different segments are using our components and how they want to architect their system so that they have maximum flexibility and functionality that they request.
I'd love to pull back. This is such an interesting point you made about off-highway, and I know there's a lot of incredible innovation in off-highway sort of farming and things. You mentioned how they're using OTA in a very advanced way. One of the other data points in the survey that was so interesting was while a lot of companies said that OTA is now prevalent in their vehicle, it's also clear that they're only using it today for, I would say, largely bug fixes and in a smaller way. But what the survey said is in the coming couple of years, the adoption of using software to add new capabilities in the vehicles was expected to accelerate much more rapidly. The general trend from the survey also was just that SDVs moving away from it being a buzzword to becoming more real. And I think that one data point was a really key statistic that said that's the tipping point when you add new capabilities. So as we talk to people, I think sometimes there's a reticence to think, oh, well, how can I add new capabilities after shipments? And I think that's a huge fallacy. I'm wondering what your take is on that aspect.
Yeah, it's a great question, because the expectation that we're kind of setting with customers now is what I said before, is there's improvements over time. But there's a high dependence still on the hardware to support that. And generally speaking, we don't build more into the hardware than we need, right? So the hardware is optimized from a cost perspective and a reliability perspective to do what it needs to do in the application. But if we're going to expect the software to do more, we may have to provide additional functionality in the hardware too to support it. I'm talking not as much about digital cockpit, and it's clear with apps and things you can bring new functionality in different ways. But if we want to bring it to mainstream, portion, our brake controls and things like that, we have to make sure that we're ready to do that with respect to the hardware as well. And I don't see as much of that yet, but I could see that coming. But we're kind of separated with respect to those two domains.
I see that, absolutely. And we've had several guests on the podcast talking about this topic and how it's challenging today with today's metrics of success to build in headroom, because it bakes in cost effectively with uncertain revenue. So from an accounting perspective, it's red ink from day one. But one of the interesting aspects in the survey we asked was about how much headroom people can build in, and there were various answers across different price points, low, medium, and high. But I observed that as one consolidates from many ECUs, in which case to build in headroom, every ECU would have to have headroom, to more consolidated ECUs, fewer consolidated ECUs, you have the potential opportunity to share headroom. So you don't it actually in an aggregate, you have to bake in less costs to keep headroom. Do you see that as a viable direction and one of the upsides of consolidation?
Yeah, absolutely. I think the microprocessors that we're building into vehicles today are really fascinating compute platforms that really have a tremendous amount of capacity. I'm sure that our engineers will figure out how to use it all eventually. But from where I see today, the differences between the microcontrollers of yesterday and the microprocessors of today, there's really no comparison in terms of what's available. But it's more than just compute power, right? So if you really want to add different functionality into your system, you may need additional actuators, you may need additional inputs and outputs, sensors. So it's not just a flash over the air activity, right? It could be that you're adding hardware to the vehicle as well. So I don't think compute is the limitation, at least today. I think it's more, what do you want to do, and what additional sensors and actuators would you need in the vehicle to fulfill those requirements? Again, setting aside digital cockpit with apps and entertainment and things like that, which can be brought in purely with software.
Joe, this has been an incredible conversation. You're such a huge resource of having a great perspective across the entire system, as you said. I've really enjoyed the conversation, and we're really grateful for you visiting with us today.
Okay. Thanks so much, John, for having me on.
If you like what you're seeing in this episode, please like and subscribe to see more from us, either from our episodes at AutoTech Detroit or from our home studio. We look forward to seeing you again in another episode of The Garage very soon.